As a reminder, we have a homework check tomorrow. I kind of talked about that yesterday. I'll give you more info on it tomorrow, but be ready to have A1, A2, A3, or A4. Remember, I'm going to pick 2 out of those 4. You need laptops on Monday. You need to join AP Classroom on College Board. It's a requirement of the course. It's a homework assignment for me, and we're going to be on it on Monday. If you are having trouble with your password, is there anybody here that's having trouble like getting into their? Because I don't spend the whole time talking about it if nobody does. Anybody having trouble? Okay, talk to me if you are, and I'll tell you what you have to do. And then next Wednesday we'll have a quiz on 1-1 and 1-2. Okay? So everything pretty much today that we're doing is reviewing. This lesson involves pretty much reviewing everything we've been doing. Okay? We're doing a lot of AROC again. All right, so let's review that formula for AROC. Remember, AROC means average rate of change. We talked about it being a slope, all that stuff. And this is the traditional formula. But I had a few of you, and whenever I say you guys, I mean my pre-calc students in general. I don't necessarily mean this class, but I had a lot of you ask me, well, I noticed on your key the order was changed. Remember, as long as the Y's are on top and you keep the order the same, notice first or the second, you get the same answer. Okay, so either one of these are fine. Y's on top is non-negotiable, but the order you put the Y's in doesn't matter. You choose. But whatever order you put the Y's in, that's the same order you have to put the X's in. But same idea, okay? Now, understand what we have been doing. I want to understand what I'm about to show you. It's going to take making sure you understand what was this. Like, at its base, I think all of you kind of get finding slope between 2 points. Like that, for sure, I think you guys got. That's what we were doing over and over again yesterday, what we're doing over and over again today. But what does it mean, okay? So you don't need to draw this. I'm just going to make up a graph, okay? Just call it this, that. What? Yes, I am. Thank you. So there's some curve on the graph, okay? And what we're at, all of this AROC stuff is find the slope on an interval of this graph. Interval is part of the x-axis. So if I said like from 1 to 2, okay, what that means is from right here to right here. Could have picked better points, but you get the idea. What is the average rate of change between those 2 points? Let me make it bigger, like 1 and 4, okay? So between the first point and then where's 1, 2, 3, this point, okay? So from here to here, okay, that's this one right here. What is the AROC? What you're really finding is the slope of this line that goes between those 2 points. Why is it called average? Well, because there's a whole bunch of, you could break this, I don't want that red dot there. You could break this interval, this chunk, into smaller pieces if I did it between here and here, or here and here, 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 here. Any of those smaller ones, I would get different answers. They'd all be different. So by doing these two, I'm getting the average of all of them, okay? It's an average, okay? What this next concept is something called instantaneous rate of change. Instead of finding the average between 2 points, you find the instantaneous rate of change at 1 point. I want to know what's the slope right there on a curve, okay? To do that properly, we need calculus, and we're not in calculus yet. So you won't be able to find exactly the instantaneous rate of change, but we have some ways of estimating the instantaneous rate of change, okay? So I'll come back to that picture in a second. So what we have here is a word problem. I'm going to read it, like speed read it real quick. Suppose an object is launched upward from a height of 120 feet with an initial velocity of 48 feet per second. The height of the object t seconds after it's launched is given by blah, blah, blah. So all of that I just read is made into an equation for us. There you go. All right. Find the AROC, so average rate of change, in the height of the object over these 4 intervals. That's a lot of work. We're not going to do all 4 of them, don't worry. Okay? So this is exactly what we did yesterday. Now, and we're going to do one of them to remind ourselves how to do it. And then I'm going to talk about how we could use what we did right here to find the instantaneous rate of change at like t equals 1. If you notice, look at these intervals. Remember, these are x values. This is 1 and 1.1. That's a really, really small, teeny tiny part of the graph. And it gets smaller and smaller and smaller. All of these intervals are showing what's happening really close to 1, right? So let's just do the first one, and we'll talk about what to do after that. So I'm going to find the AROC between these two x values, and I'm going to make it very painless for you so that we don't have to do a lot of work, okay? So let's remember that these are our x values. This is going to be a decimal, so give yourself a little room there. So those are my x values, and sometimes we can get the y values from a table of values, from a graph. In this case, we have to plug in the number, okay? Let's just do one of them, and I'll give you the answer to the second one, okay? So h of 1, right? I'm just going to use this space right here. So h of 1, when I plug a 1 in to this function, it would look like this. And we're just going to type it right in our calculator, okay? And I'm just doing one of these to remind us how to use the calculator and all that. So I have negative 16, open my parentheses, put a 1, close my parentheses, square it. Remember, your cursor's up in the air. To bring it down, you hit your right arrow, plus 48 times 1, plus 120. Okay, and then you can hit enter, and you get 152. Okay, now we technically have to do the same thing for 1.1, okay? I did the work for you. Let's not waste time. I think we all know how to do the same exact thing, but instead of a 1, we would put a 1.1. This is the answer you will get, 153.44. Again, I didn't leave myself enough room. I'm going to write this down, 153.44. Okay, so to do the AROC, you need 2 points, right? Now we have the 2 points. Jacoby, do you have your notes out? I didn't even look around. I would figure you guys would know. You have to have your notes out. You should be writing it. All right. We still haven't even done the AROC part. All right. AROC is, I'm going to use second one first. Second y minus the first y over second x minus the first x. Just like yesterday. Remember the order. You can change it like we talked about at the beginning of class. Put this in your calculator. Trust me, I did it for us, and you'd get 14.4 when you do this work, okay? Feet per second, if you want to be really technical, okay? So the AROC of this interval, the average rate of change between that is positive 14.4. Now, technically, we're supposed to do the same thing 3 more times. That's busy work, not going to do it. Let me give you the AROCs for all of these, okay? And I didn't give you one of these to do in your homework either. This is to help you understand this concept, okay? So let's pretend we just did all that work. We found the AROC, the AROC, the AROC, the AROC of smaller and smaller of sections of a graph really close to 1. Because the next question is, using those AROCs, what do we estimate as the instantaneous rate of change at just 1, not between 1 and something, but just at that single value? And you would pick the one that is the smallest. In this case, trust me, that's the smallest. And you can see, like, this one's pretty far away. I mean, between 1 and 1.1, you would think that that's a pretty small interval. But we were able to get even smaller, smaller, and smaller. And by doing that, the numbers were getting really, really close to 16. And we could keep going. I mean, that's why this is an estimate, guys. I mean, how many decimal places can we go out? We could keep going out, making the numbers smaller and smaller and smaller, and this number would keep changing, okay? So that's why this is not a perfect way of doing things, okay? But I wanted to introduce the idea to you. That's one way of doing it. That's the way that we just did. So to find an IROC, one thing you could do, which you're not going to have to do, is to use the average rate of change over very small intervals and see what you you get. There's a second way, which I'll show you on the next page. All right? But let's take a pause before I do that, and I want to show you these. These are kind of neat. This is where I'm going to show you some cool things on your graphing calculator, okay? So you're going to definitely use your graphing calculator for this. So for each of the following functions, describe the average rate of change over the given interval as positive or negative. That's all we're saying, okay? And we're not going to use any math. We're not going to actually do AROC. Because we could certainly make ordered pairs, do the formula, and then we get a positive or a negative answer, and we could answer that. But there's a faster, easier way, okay? What we're going to do is look at the graph of it, all right? So let's see what y equals x squared looks like. So what you're going to do, so pay attention, so you know where all the buttons are. Go up to y equals. And if you want to clear your RAM, because last period they were playing with it, to clear your RAM, you would do the second plus 712. So feel free to get a clean sheet of paper and get all the stuff out of there that the last person was doing. I would do that every single day when you pick up your calculator, and you'll start remembering. And it should say RAM cleared on your screen. Okay, guys, go up to y equals. So y equals, okay. If you didn't clear your RAM, you can just hit clear right now and it'll take out whatever was there, okay? But if you cleared your RAM, there should be nothing there. And we're going to type that in. There's an X button on this calculator. It's right next to the green alpha button. See, it says X, comma, T, comma, theta, comma, N. So X. And you know how to do an exponent. And Q. Once you type that in, you can just hit graph. See it right here? Hit graph, and it'll graph it for you. Another really cool thing that we can do is look at the table of values. Let's pretend that you actually had to, I gave you a piece of graph. This is not going to happen, but I'm like, graph this perfectly on a coordinate plane, and you wanted to know what those points are. You can find the table of values right here. See how it's blue? Well, if I hit second table, there's all your X's and Y's, and you can, arrow through them if you wanted to. We're not making an exact graph, so don't worry about that. The graph, just looking at the graph is good enough. So if I sketch that graph, it would look something like this. A sketch is a sketch is a sketch. It should look something like that. Don't stress about it, okay? What this question is asking us is on the interval from 2 to 3. I'm going to pretend that's 2 to 3, okay? So that would be like this point and whatever this point, What would you guys say? Is that positive or negative? Is the slope positive or negative on this interval? Positive. That's it. That's why it doesn't have to be exact. Because anything to the right of 0 is going to be a positive rate of change. Anything to the left of 0 would have been a negative rate of change. Okay? Let's do another one. Go back up to y equals, and you can just hit clear to get rid of it. And we're going to put in a log. Now, you don't have to remember learning logs last year. It's no big deal if you don't remember how to graph a log. We're just looking at a picture right now. So hit the log button, which is right next to 7. And it automatically opens parentheses for you. We're going to put the X in there. And listen, that's all we have to do is log X. You can close the parentheses, that's fine. But on these calculators, if that's the end of your sentence, if there's nothing else to type after it, you don't have to bother with closing it. Your calculator knows, oh, she must be done or he must be done, okay? But if you do close it, it's fine too. When do you have to close it? Well, if you're going to put like a +1 or something outside the parentheses. All right, let's see what that looks like. I'll remind you that the graph of a log has a asymptote over here. So it actually, it's hard to see on that graph, but it looks something like that, okay? But again, it doesn't really matter how great our graph is. We want to know, are we positive or negative on that interval, which is somewhere in here, right? Well, the whole thing has a what type of rate of change, positive or negative? Positive. It's rising left to right. As we go left to right, we're going up. That means our rate of change is positive. So that's why it doesn't have to be so perfect. This whole thing is positive. Okay? Let's do one more. Y equals, clear it. So we're going to open parentheses, and then to put 1/2 in, you do 1 divided by 2. You guys, that's 1/2. That's 1/2. To the power of x. So it looks like a backwards J. And from -1 to 0. So I'm just approximating that as -1. So this interval of the graph, positive or negative slope. You guys, are you getting what I mean when I say positive or negative? Okay, so as it falls left to right, that would be negative. Didn't ask what the slope is, just positive or negative, okay? So just being able to kind of look at a graph, zero in on a part of it, and evaluate what's going on there, okay? All right, on to the next page. See, I skip a lot. You don't need to do every problem. Okay, remember I said there's a second method to find instantaneous rate of change, okay? And that is using a concept of a tangent line. So look here. The graph of f is shown at the right. The tangent line, I'll explain what a tangent line is in a second. The tangent line of f at x equals -3 is shown, okay? In calculus, we will prove that the slope of, okay, we already talked about that. So here's the graph of f. Here's a point at -3, okay? A tangent line is a line that's drawn here for you that touches a point, touches a graph at a single point. It's only touching this curve at this one point. That is a tangent line. Where did you put it? Oh, over there. Okay, thank you. Yesterday, and I didn't talk about it, if you're finding between 2 points, see the lines that went through all of the points on our graph? We were finding the average rate of change between 2 points. This is called a secant line when it goes through 2 points, okay? We'll talk more about that coming up in a future lesson. But this is a tangent line that touches at 1 point. So what we want to know is what is the instantaneous rate of change right here at this point? Well, remember I told you we can't do that till calculus. This method was pretty intense, lots of work. But using the tangent line is a great way of doing it. Here's the thing. If I know the slope of this line, I can use that to say that's the slope right at this point, okay? And we know how to find the slope of a line. We've been doing it all day yesterday, and we've been doing it today, which is pick 2, and on this you can pick any 2 points you want because it's a line. Pick 2 points, find the slope. That would be the slope of the tangent line, which we then use as an estimate of the slope at a single point, okay? So pick 2 points off that graph. -3, I know it's a little above 3. Let's not get too technical. Let's pretend it's right at 3. We don't want to deal with the decimal right now. And find any other point. Remember, on a line, it doesn't matter. Any 2 points. And I think this one's a good one. -2.7 is that? Yeah. But any 2 points. You just want to pick points that don't have decimals, like that you can easily name. And I'm going to actually use m, because this is the old-fashioned Algebra 2 level slope. M. Second y minus first y over second x minus the first x. We would get 4 over 1 or 4. It should make sense that we got a positive answer. This tangent line is rising left to right. It should be a positive answer. So we would use that as an estimate of the IROC at x equals -3. Okay? It's an estimate. It's not perfect. You can't be perfect till you learn derivatives next year in calculus. Okay? All right. Let's just sketch tangent lines at the other 3 points. It is not easy to do. This one's easy. I can draw that one. I'm only touching the curve at that 1 point. It's hard to do it here. I'm not good at it. Understand that 1 exists, but your teacher is not good at it. So something like that. It would look like that. What? If this keeps going? Yeah, I mean, these are not connected in any way. We're just saying, okay, what would a tangent line look like here? Okay, you're not actually doing anything with it. See, my line is curving. Okay, I don't have a ruler. It doesn't matter. The only thing I want you to get out of that is what a tangent line is. It touches a graph, curvy graph, at one single point, no other point. Okay, These are all independent of each other. Don't overthink it. Yeah. Okay. So that was part B. Yeah. See what's happening here. What kind of slope is this? What is the slope right there at x equals 2? 0. And I just want to remind you of that. It was just a good moment to do that. And that's a horizontal line. And the way I remember that a slope of a horizontal line is 0 is because there's an O in horizontal, so that's like a 0, O, 0. Vertical lines, you guys remember the slope of a vertical line? Undefined. Good. Okay. Not really part of the lesson, but thought we talk about it. Okay, last concept that we're going to, and this is review. I get really excited about this. This is everything. What we're going to talk about right here, and we're going to practice one on the next page, is such a huge concept of this class, okay? I've already taught it to you. This is a review, okay? I've already taught it to you. But it's something that confuses students all the time. In fact, last period, everyone was super confident. We went over, and everyone was like, yep, nodding, I get it, this isn't hard. And then when we did an example, they were like, just when I thought I had it. So listen to me, okay? This is so important that I'm going to stop teaching tomorrow. I'm going to give you a worksheet called 2 Truths, 1 Lie, and it's all a review of this. There's going to be a graph. It has 2 true statements and 1's a lie. You have to figure out which one is the lie. Just doing this, okay? I'm not going to sit up here and talk. You're just going to work on that stuff. I'll walk around and help because it's so important that you understand this concept. It's all year long we talk about it, okay? So here's the thing. Let's fill in this little table. We can talk about the rate of change of a graph, and we can talk about just the graph, okay? So very specific part of the graph and just the graph. If we're talking about the rate of change being positive, if the rate of change is positive, what does that look like on the graph? Is that increasing or decreasing? Does that make the graph increase or decrease? If a slope is positive, we're increasing, right? So if the slope is negative on the graph, we would say the graph is decreasing, okay? Now remember, this is where my lovely students get confused. Whenever we're talking about rate of change increasing and decreasing, this has to do with concavity, okay? So if your rate of change is increasing, that does not mean it's positive, guys. Remember my picture I showed you? It means it's getting bigger. That is concave what? You guys remember? It's up. The trick I taught you, concave down. And we're going to see this visually in these last couple examples here, okay? This is so, so important. I tutor a girl at Calvary Christian. She and I spent the entire session, an hour, just reviewing this because it's so important, okay? So let's look at this graph. And guys, save yourself time. You don't have to write unless you really want to. Just circle the answer. The graph of G, would you say the graph is increasing or decreasing? What's happening here? You can just call it out, guys. Increasing or decreasing? It's increasing, right? Is this graph concave up or concave down? I hear down and up. It's up. This is concave up. Remember, concave up holds water. It opens up. It's a broken bowl. Okay, here's my bowl, concave up. It's broken, but it's still the part that's left is concave up. Okay, it's opening up. Do you see that? Okay, it's concave up. So is the rate of change, sorry, let me say it differently. Is the rate of change on this graph, is the rate of change positive or negative? Positive, because we're increasing, right? Increasing and positive go together. And is the rate of change increasing or decreasing? Increasing, because if you're concave up, your rate of change is increasing. Okay? Say it again. Here's what's confusing. We use positive and negative and increasing and decreasing lots of different ways. You have to read really carefully. Here's last example. This is really, really, really important, okay? So guys, I need to say 2 things about this graph, okay? So let's start with this. Would you say the graph is increasing or decreasing? It's decreasing, right? It's decreasing. It's going down, if that helps you. It's always left to right, okay? All right, is the graph, okay, we haven't talked about this since Monday. Is the graph positive or negative? Positive. Where does that come from? Y values.
Y values.
Yep, if we're above. Guys, that question right there that I just asked you would never be asked if the graph looked like that, right? Because there's some that are positive, some that are negative. It would only be asked if it was clearly either positive or negative, okay? All right, is the rate of change positive or negative? Think about it. Rate of change, positive or negative? Negative. We are falling. Remember, like a line, it's falling left to right. That means a negative slope. Is the rate of change increasing or decreasing? In. Right? Because it's concave up. Still part of a bowl that's opened up. The bowl just broke, so we're missing that piece. But it is concave up. Okay? Concave up. This is the one a lot of people got confused on. They're like, I got it. It's clicking. So be careful. Think. Okay? Is the graph increasing or decreasing? Increasing, right? We're rising left, right. The graph is increasing. Is the graph positive or negative? Negative. Okay, good, right? I think we're good on that one, it sounds like. Is the rate of change positive or negative? It is positive. Good, because we're rising left to right. Is the rate of change increasing or decreasing? I hear both. Decreasing, because we're concave down. This is where students get confused. How can you be positive and decreasing? It's okay, you can, okay? These are positive slopes because we're rising left to right. And if you are concave down, your slopes are decreasing, D's. So those are all these things you can be asked, and you can see how you can get them all mixed up and confused. That's why I'm spending a whole day on it tomorrow. Okay? Yay. Homework time. Page 21. 21. Make sure you write A5. Just these problems. I will put the key up for you. I am happy to help you. I'm happy to have you work with your neighbor. 17 is trying to trick you. Don't let it happen. When you get to 17, before you start it, I would look at my little notes to you up here. That way you don't have to do it a second time correctly. I always write you little notes on the problems to help you. We always round to 3 decimal places if you have to choose. The whole year, the entire year, 3 decimal places, and the AP exam. So we just start at the beginning of the year rounding correctly, and we do it the right way all year. You will lose a point on the FRQs for not rounding to 3 decimal places. So we're going to do it from the beginning of the year all the way to the end. Okay. Let's get started. You have a question? Yeah, we did stuff yesterday. We had a lesson and homework yesterday. So you go in Canvas. Are you familiar with Canvas? Okay, yeah. That's what I was saying at the beginning of class. Anytime you're absent, it's your responsibility to go on Canvas. And I have a video, all the notes, all the keys to homework, basically like being in class from home.